Cambridge. He will be talking about Audible XR, the practicalities of mobile system transparency. So without further ado, let's.
Yeah, thanks for the introduction. Yeah, as mentioned, my name's Singh. I head up the Compliant and Accountable Systems Group, University of Cambridge. This is working in collaboration with my colleagues Chris and Richard, and really going to be talking about how we make ubiquitous computing systems, XR systems, more transparent. So we all know this game Pokemon Go. We chase these virtual critters around the physical world. Got to catch them all, is the catchphrase. What you might not have heard of is the Pokemon Go death tracker, where usage of this application has been associated with various injuries and deaths, guiding people into areas they shouldn't have gone, distracting them, and so on and so forth. And I use that just as an example to show or highlight that incidents of harm will occur with ubiquitous computing systems, with XR systems, even in application environments that might seem quite benign, such as games. And when these incidents inevitably occur, we will need information on what happened, what led up to this issue occurring, and what were the contributing factors, where did the fault lie, and so on. And so we see this kind of increasing call generally for computing systems to be more transparent. There's a lot of sort of social demand, regulations calling for these sorts of things. But I think extended reality is a particularly interesting environment for exploring this, because how it works is the coming together of the user, the technology and various technical components, and the physical environment. These aspects come together to drive the system functionality, but also means that these systems have real-world physical effects. So it's this tight coupling between these three components, with these many degrees of freedom which each one of these components give, means there's a high propensity for things to go wrong, things to fail, right? And so if we're designing XR systems, it'll be very hard for a developer to preempt and design for all potential risks their system might get exposed to, because a user can potentially do anything, they can take it to potentially any other environment. You've got a whole range of different technical components maybe embedded in the environment which you need to interact with and so on. You can't predict or preempt all the situations or contexts that you'll be exposed to. And then when things go wrong, you get tangible harm to persons and property as a possibility. And that's over and above the traditional harms from computing systems where you might have like data leakage and other harms associated with that are a bit more intangible. So transparency is important here because it can assist us in understanding what happens within systems, what are the contributing factors when a particular incident occurs, and so on. And that's really kind of the focus of this paper and kind of a theme of work that we're looking at the moment, and is how do we provide information to support review of these systems. And it's actually not unlike what was presented in the keynote today. How do we actually understand what's happening within systems? And what we're focusing on specifically is about having the data for recreating the context of use so that we can explore what happened when a particular incident occurs. So we were looking around and saw there wasn't actually a lot of tooling out there to support people with this. So we built something. It's called Droiditor. It's an auditing toolkit for Android. Essentially what it does is captures and records data to enable a contextual review over what was happening within a system. You can basically think of it as kind of a logging framework on steroids. It basically, for a device, can start capturing things about the inputs, all the sorts of things you'd expect, such as camera, microphone, sensors, network connectivity, controller interactions, and so on. Various things, the outputs, what's presented to the user, screens, sound, interactions through the network, as well as allowing developers to annotate or record aspects of application state as well. It's highly configurable, so you can change it and tailor what you record to a specific usage context, which is important when you're thinking about transparency. And we set up these things called audit pipelines where you can build your own modules and plug them in. So for example, we had something that you could plug into your camera feed as that's being logged and automatically detect and block faces so that you're not persisting people's faces in the audit log. That might help in some situations with dealing data protection concerns, maybe not in others. There's a link to the GitHub there. I'll show it again at the end. So what might this sort of stuff help you do? Well, imagine you're walking down the street, there's a hole in the ground, you injure yourself, what happened, sort of thing. So you can go to the logs and see, okay, well, this is what was presented on the screen. It was an overlay on the street saying, here's your destination. But if you compare that to the camera feed at the same time, you can see, oh, there's some open manholes here. Maybe that was a contributing factor to the particular incident. We did some previous work as well, exploring how various harms can come up in augmented reality context. For example, like overlays misdirecting people or telling them to do the wrong thing or components failing and so on. So I'll give a link to that paper at the end. But really what we're talking about here is that data that indicates what the user was doing or some aspects of the environment as well as the system context can enable us to reconstruct or recreate a particular situation, give us information about what was happening as the system was being used. And so this enables audit, interrogation, understanding, review, scrutiny, challenge by a whole range of different stakeholders. Developers can use this sort of stuff to make sure that these things don't happen again, to debug and so on. Users and operators can do these things to better understand the system, how they're interacting with the system, maybe for training and so on. Investigators might be interested in this for apportioning responsibility, fault, liability, and so on. So we built this thing to try and start recording information to enable transparency, to enable auditing to occur. But what's important to also consider is that when you start recording data, this has considerations. And so quite often there'll be tensions between supporting transparency aims and a whole range of other sorts of aims as well. I won't go through many of them or any of just one in detail, see the paper for more, but one aspect is around completeness. So that one question comes up, well, if you're going to have your system being audited, what do you record? And kind of the intuitive answer might be, well, let's record everything, right? Because if you have as much information as possible, you have as much information as available that's there to kind of piece things back together to work out what happened when something goes wrong, for instance. But we all build systems, and we know systems have overheads and so on, and we do some overhead analysis in the paper, but just as an example, if you record everything at kind of like full fidelity, as much as possible, we're generating about maybe 2 gigabytes of data per minute, which on a 64 gig device, well, gives you half an hour of use. Maybe that's appropriate, maybe that's not. It will depend on the particular context. So then you need to kind of make decisions or trade-offs. Well, what do I record? What don't I record? Or do I record things in a different way? So for example, we did things such as through the framework, you can kind of reduce the quality of the images that are captured, reducing the size and so on, which might be perfectly fine for one situation if you're playing around with an engine, you just want to see sort of what components someone's interacting with. That same process might be completely inappropriate for a medical context where you might be messing up the skin tone or something which might have clinical significance. The key point here is really that the issues and considerations will be very much context and domain specific, so we need to think about what these mean in different contexts and how best to support that. Another aspect which we cover in the paper, but I don't have time to talk about now, are the privacy and data protection considerations. That will also bring a lot of, well, needs lots of thought, and we heard about that in some of the previous presentations as well. Ultimately, when you're talking about transparency, quite often you're building some sort of surveillance apparatus, so we need to think very carefully about what this means in practice. I think more broadly, I mean, really what this was is kind of highlighting that there's many research opportunities in this space. We elaborate some in the paper, there are some listed on the slide here. I think some interesting things include how do we meaningfully present information from systems to different stakeholder groups, like what a user of the system might need in a kind of operator sense is very different from what a developer needs, is very different from what a regulator needs. Also, some of this stuff kind of related to the keynote as well, so through in I don't know how to pronounce it, but that train thing at the back. So yeah, there's like how we can kind of instrument systems better. I think there's a lot of interesting things there. So the key takeaway message is that ubiquitous computing systems, extended reality systems will need to support transparency. There's increasing public demand for this sort of stuff. There's new regulations which will be mandating certain record keeping, that certain record keeping occurs. So we're going to really need to think about this as a community. So really it's just a call that there's more research needed in this space. We've done a little bit of thinking in this area, not only for extended reality systems, but kind of broader sensor-driven systems as well. So if you're interested, please do have a chat. And otherwise, yeah, happy to speak afterwards. Thanks.
Yes, for the wonderful talk. Any quick questions? Have any quick questions? So our next speaker is Katharina Pohen. She will be talking about surveying the social comfort of body, device, and environment-based augmented reality interactions in confined passenger spaces using mixed reality.